Very good morning, students. Today we are going to learn about analog electronics laboratory and that on linear integrated circuits applications of Opamp schematic trigger circuit, schematic trigger using Opamp. So we'll go to the circuit diagram. This is actually the circuit diagram for a schematic trigger. So it is basically a comparator application. We have two inputs giving two inputs. One is at the the sine wave input is given to inverting input terminal of Opamp. We know that Opamp is 8-pin IC 741. To the pin number 7 and 4 we are giving the VCC supply. That is VCC can vary from plus or minus 12 volt to plus or minus 15 volt. And we have two input terminals. One is inverting input terminal and other one is non-inverting input terminal. And we have the pin number 6 as the output pin. So other two 1 and 5 are known for offset null. Here go to the circuit operation schematic. So giving the input sine wave to the inverting input terminal, and non-inverting terminal we are giving the feedback resistor R1 and R2. Based on the R1 and R2 values, we are going to change the design values, change the output threshold limits. So when we give the input sine wave to the inverting input terminal, default due to the virtual ground property, default voltage will be there in the pin number 3 even when input is not given. Based on the virtual ground property, we will get a small output at the output, and that is fed back to the again to the non-inverting input terminal reference voltage. When we give the input sine wave, the comparator will compare both the inputs, and when the input at inverting input terminal is high when compared with non-inverting terminal, a negative going pulse, that is minus Vsat, will be generated. And when the case is being reversed, that is the reference voltage is, this voltage is greater than the input voltage applied at inverting input terminal, it will be generating the positive going pulse. So alternatively, plus and minus, that is plus Vsat and minus Vsat is being, the signal levels are being generated based on the input and the reference voltages. And this output is we are collecting at the pin number 6 using the CRO. Now this is what the circuit operation, and we have the design equation like this, that is upper threshold equal to lower threshold value equal to, that is the threshold limit is being determined by the values of R1 and R2 resistances used in the circuit. That is these two resistance values used in the circuit. Based on this, we will get the upper threshold and lower threshold. So this value is being given by R1 plus R2 into V saturation. So V saturation, if we give the supply voltage as plus 12 volt, that will be plus 12. If we give the voltage as 15, and that will be plus 15. So here for example, if we give the voltage as 15, I calculating the values for this, and we get the values, design values as 6.8K. So that value only we are using it in the circuit. So upper threshold and lower threshold is being common, same, and for a V saturation voltage of 15 volt, we are determining the threshold values, and that is threshold limits, and we get the values of R1 and R2 to be 6.8K. So directly we go to the circuit operation, circuit connections. So Opamp 741 is being connected. Pin number 7 is connected to positive of supply. Dual power supply will be using it. So this will be going to plus 7 volt plus 7th pin, and this will be grounded. And if we want to use the minus voltage, this will be connected to the ground, and this point will be connected to 4th pin. That we know that dual power supply we are giving it. I am setting the voltage to be of 12 to 15. Okay, and we have a sine wave function generator. We set that to particular knob, that is sine, and we are connecting the CRO. Both the input terminals we are using it. After giving the connections, that is supply connections, and function generator input is given at this R2 6.8K, which is being connected to pin number 2, and pin number 2 and 6 is being connected with a resistance value of 200K, and pin number 3 is connected to a 6.8K value that is being grounded. So these three resistors and we have a load resistor value of 4.7K at 6th pin. So only 4 resistance values and the op-amp, and we are giving the supply. And to this input, that is the second inverting input terminal, we are giving the input sine wave. So at the 6th pin, we are going to measure the output. So the output is bearing the first channel output, so that will be the sine wave. This is the sine wave input given, and this is the square wave output we get. We can vary the time duration. We can just see the perfect square wave, and if we bring the input as a perfect sine wave, we can just vary the time duration. Amplitude also varied. Amplitude can also be varied. So by varying this, we can measure the square wave output. So merely Schmitt trigger is a comparator circuit which compares the reference voltage with the input sine wave. Whenever the sine wave input exceeds the reference voltage based on the virtual ground property, it generates the plus V saturation, that is positive part of the square wave, and when it is below that value, it generates the negative pulse of that value. So you can see a perfect square wave for this. So for this purpose, we can also call that Schmitt trigger as a sine to square wave generator. That is very important application of comparator application of op-amp. Thank you.